Hey everyone, and welcome back. I'm Amari, your Perpetual Tech Noob, learning more with you. And as you can see, I'm going for another easy 1 hour Algo Challenge today. So let's just get it in, right? Let's start this clock and pick one. Let's go. Remove all adjacent duplicates in a string. You are given a string S consisting of lowercase English letters. A duplicate removal consists of choosing two adjacent and equal letters and removing them. We repeatedly make duplicate removals on S until we no longer can. Return the final string after all such duplicate removals have been made. It can be proven that the answer is unique. Okay, the input. Well, first of all, let's go to the constraints, right? In the constraints, the string length is anywhere between 1 and, 100,000 letters inclusively. S consists of lowercase English letters. Okay, going to the first example, we have ABB ACA. And the output is CA. From my thoughts, I would have figured A and B, right? So you move forward and then you have the two B's, right? So I would figure that the second one would get removed. And then you would have A and then CA. So I would have figured A, B, A, CA, but evidently I'm wrong. Let's get the explanation. For example, in ABB ACA, we could remove BB since, they're removing both of them. A duplicate removal consists of choosing two adjacent and equal letters and removing them. Hello? Reading comprehension, sir. Okay, so at first they moved the BB, right? And then the A slipped down. Then you had AACA, and then they removed the AA. Okay. We could remove BB since the letters are adjacent and equal. And this is the only possible move. The result of this move is that the string is AACA, of which only AA is possible. So the final string is CA. Okay, understood. In input 2, the string is AZXXZY, and it ended up being AY for the same reason. You removed the XX first, and then you had the ZZ after. So how can I do this? Because I was thinking at first, my initial intuition before realizing this, my initial intuition was to use two indices, a double index sliding window. But if I used that, it would have been AB, and then I would have moved from the A to BB. It would have been AB at first, and then since there's no removal, it would have moved over to the next index, BB. And if I remove that, then I would still be on index 1, and the A will slip down, and I would end up looking at AC, right? Because I would have still been at index 1. This would have been the new index 1. So I'm going to have to find something else. What can I do to set it that first I'll remove Hmm. For easy, this is a little on the complicated side. So what can I say? Okay, here's what I'm thinking. Not exactly a sliding window, but let's say a sliding window, right? It will be a sliding window basically. But the sliding window will only have two indexes, right? We'll only look at two indexes at a time. And what I will do is I can have an index as a variable. And I can say until the index plus one, until that index while the index is less than the length of the string minus one, because evidently we'll be altering the string the entire time. But if I have it as less than a string minus one, until the index reaches the last letter. So yes, length of the string minus one. I will go through every index of the string and I will look at the item that comes after it, the letter in this case that comes after it. And if both of them are the same, right? If both indices equal each other, then what I will do is I will remove those two indices, right? To do that, I could say I'll remove the current index, and then I'll remove the current index again, because of course the secondary letter would slip into that same index spot. And then if that happens, if I do find a match and I do have to remove those two, I'll bring the index back to the zero spot, back to the starting spot. And then I could continue on, and every time I do find something to remove, I'll start again from the beginning. And then when it finally reaches the last letter, the last index, I'll know that I could stop there, because of course nothing else will come after that. So let's try this out. I said I was going to use an index as a variable. So let's call it current index. Current index I'll put as the zero spot, right? The very first item in the string. So current index equals 0, right? And I said that I'll make it whereas a while loop while the current index is less than length of string minus 1. So while the current index is not the very last item in the string. So while current index is less than the length of string minus 1. Now, to progress, I will have to say if current index, if S current index is not equal to S current index plus 1. And that way I could say current index plus equals 1 to move it over. So if current index if S of current index, if that particular item if S current index is not equal to S current index plus 1, like I said a second ago, that's when I will move the current index over 1. So I'll current index plus equals 1. Current index plus equals 1, right? If that's not the case, if they do happen to match, then what I would do is I would have to basically remove those two items, right? So it'll be s.pop current index and to remove the other item that matched with it, I'll have to do that again. So I'll do that twice. And then what I said was that I am going to put current index back to the 0 spot so that it could do the check all over again from the very beginning. So current index will then be moved back to the beginning. And if I'm correct, that'll be it, right? I will have to return S afterwards. So let's take a look through this. Current index. Let's grab this so we don't have to go back and forth with the camera. I don't have to grab another example. Current index is 0. While current index comes before the very last item, what I'm going to do is if the current index of S and the current index plus 1 of S are not equal, then current index will move over 1, right? And if they are equal, let's say it moved over 1 and then I did the check again, if S of current index, if the current index of S, pardon me, is equal to the next index over, right? This is the else statement. I will pop the current index, and then of course that secondary one will move over and I'll pop that current index again, and then current index will equal 0 again. It'll start from the beginning. So then now it will be without the two B's. And since I'm starting over at the beginning, I'm going to do the check again, right? And I'll look at them, and seeing that this statement isn't true, I'll go to the else, pardon me, I'll go to the else, and then I will pop, seeing that it is the same, I'll pop that current index, and then this one will move over and I'll pop it again, right? And after that, what we'll have is the CA. Now, the current index the current index of S, which will be 0 again, because I'll move it back down to 0, is not going to be equal to the next item, right? So I'll say current index plus equals 1. So now I'm over here. But then when it comes back to loop over, it will say while the current index is less than length of S minus 1. Length of S is 2, minus 1 is 1, but I wanted it to be less than 1, so then it should finish. So I'm going to run this with a hope and a prayer, but it shouldn't be necessary. Okay, indentation error of return S. Oh, you have to pay better attention, sir. Let's try it again. Okay. The string has no attribute pop. Okay, because it's not a list. Oh, okay. So what I can say instead of, because it's not a list, so instead of S pop, I can say instead should I remove? Can I do remove instead? Will that actually work? I'm not too sure. S.remove. No, because the current index will be a number and there will be no numbers in there. So I guess I'm gonna have to add slices together. So S would equal the slice of S to current index, right? S from the beginning to current index, because it's exclusive, right? A slice would be exclusive. So the current index will not show up. It'll be the item before the current index that will show up in that particular slice. And then I'll have to add that to S, and we'll start from current index plus 2, because current index plus 1 is also supposed to be removed. S, current index plus 2 to the end. So S current index, because the starting one is inclusive. So to the end. Okay, let's try that now. Okay, I think that is good enough to run it. And evidently I didn't make any mistakes with the syntax. So let's run it. Time limit exceeded. Okay. Oh, wow. $104 out of 106. I was close to the end. I'm evidently going to have to I'm figuring that taking these slices maybe is taking up the time. Probably not. I'm not too sure. So maybe I will need another variable to cut down the amount of time taken. But then how will you remove the items? And there's a lot of maybe if I made a new string, and that way, even though I'll still remove the items, right? I could make a variable. Okay, let's try this. I'm planning on making another variable to represent the string that we will return. So with that, I will always be able to look at the last item in the string that we're returning. And if the latest item that we're looking at, whatever current index is in the original string, if it happens to match the last item in the return string, then I will omit that last item from the return string, and I'll also push forward the original string. Basically, I'll omit that first item in the original string. So let's try that, right? Return string. And return string is what we're going to be returning. So, but return string is equal to an empty string right now, right? Now, maybe I shouldn't go through the trouble of manipulating the original string. because evidently that's going to take time, right? So if that's the case, then I would need another variable which will give me the original length of the original string. The length of the original string. So let's make that, right? S length will equal the length of string. So let's start this all over again. Something's telling me I shouldn't erase it as yet, but this is a different idea now. So I guess it wouldn't be too bad if I erased it. I could make a while loop while current index is less than S length, the length of the string. While current index is less than S length. The reason why I made S length out in the beginning is so that I wouldn't have to constantly look for, have the computer calculate the length of S. I'll just, since that's not going to change, since we're no longer changing it, instead of having it calculate that constantly, I could just put that in a variable from the beginning. So, the first thing we're going to do is, you know what? I can start off return string with the very first item. I can start off return string with the very first item in S. And if that's the case, then current index wouldn't have to start with 0. It can start with 1, because I really need to look at the next item to compare it to what is already in return string, the last item in return string. So I'm going to do that. And like I said, I'm going to compare it with the last item in return string. So if S current index is equal to return string, the last item in return string, what I'm going to do, if they are the same, I'm going to erase the last item in return string. But I'll also need to make sure that return string actually has a size in it, because I can't get the last item if there is no item in there, right? Wouldn't that be an error? And I know that I take off points for the errors, so I really don't want to do that. But I also don't want them to have to constantly check the length of return string. But I can So I'm going to take this, I'm going to say if return string -1, the last item in return string, if there is a value there, then of course that would allow us to go further in the check. But maybe that should be an if statement in and of itself. And just to finish off that if-else statement, if return string -1, if there is no item in return string -1, then return string would add whatever the current index of S is. And then, of course, you'll have to move forward. So current index plus equals 1. Okay, so that is the end of that statement. So how about this if-else statement? Return string does have items in it. If S current index is equal to return string, the last index in return string, then I'll still have to take a slice, wouldn't I? Current index would equal 1 regardless. We'll add 1 to current index regardless. So maybe I shouldn't do that within the if-else statement. I should do that as part of the regular while loop, the original while loop, because we're going to be moving forward with the current index regardless. So let's go back to this now. If S of current index is equal to return string, the last item in return string, what we're going to do is omit that last item in return string. So return string will equal all the items in return string up into that last item. And if that's not the case, then what we're going to do is have return string add that last item to it, the current index of S. If they don't match, we'll add that current index of S over to return string. So return string plus equals S current index. I really believe that that is it. Okay, let's look at it with this example again. Current return string already has the item A in it, right? Because we already added that item to it. And then so while current index, I can bring this down, make this a little bit more clear. This idea is null and void. You know what? I'll leave it there anyway. How about this? Just to make sure I remember that that is not part of this. Get it out of my face. Let's move forward. All right. Current index is 1, right? We're starting with the second letter or the second item of S. Return string is the first item of S, and we have our variable for the length of S. While current index is less than the length of S, meaning that it goes up to the very last index, if return string, if there is a last item in return string, what we're going to do is we're going to compare the current index of S to the last item of return string. If they are equal, return string will only equal return string up until the last character. We're going to omit the last character by changing the entire thing up until the last character. I'm glad I decided to read it before trying it out. Else, if the current index of S is not equal to the last item in return string, then we're going to add that current index of S over. If that happens, of course, we'll pass this else statement, and current index, we're going to add 1 to it to move over in whatever is the next item in the string S. If return string doesn't have a item in it at all, right? If I can't call on the last item because it has no items in it, what I'm going to do is add S of current index, right? Because from up here is already a string. So if we had removed anything prior, I'm sure it would be an empty string. It will remain a string, but it will be an empty string. But regardless of what, even if it turned into like a null item, adding the current index of S would be a particular string, so that should add back to it. And like I said, while the current loop is while the while loop is continuing, we're gonna constantly add 1 to the current index, moving on to the next item in the original string. So let's try this out. Index out of range. But that's why I made this, to see if Okay, so let's say, okay, don't get upset at the computer. It's not the computer. The computer operates as the computer operates. I am supposed to understand how it operates so I could avoid these kind of errors. If, let's say, the length of return string, if the length of return string is greater than 0, I could say, okay, but that had a runtime on it. That's probably gonna, let's hope that it doesn't mess me up more than this one. 104, that's probably where I got the runtime from, the 75 milliseconds. So maybe it'll be all right. With a hope and a prayer, let's submit this. Oh, but wow, all the way at the bottom, beats 5.35%. And I basically did good with the memory, but 5.35%. I constantly forget to explain the big O. So before I even try to refactor with 18 minutes left in the game, let me explain big O so I don't lose those 2 points. We're going to constantly be moving forward with return string, right? So that is as far as the time complexity is O of n. Now, with the space complexity, I have one variable that would constantly be an integer, and I have one variable that is going to remain the same, and it's going to be an integer. So that would be O of 1, but I have return string that could possibly end up being all of the characters in the original string. It is still a string, so part of me wants to say O of 1 as well with this. But seeing at the string length, should I compare it with should I use the string length as a reference? Or should I use the fact that it's just going to be a single string when it's all said and done? So I may be wrong, but I'm going to say O of 1 as far as space complexity. I'm going to consider all three of these a single item variable. So I'm going to say O of 1. All right, that's my big O explanation. I'm glad I remembered it this time. I think that, no, I shouldn't even consider this. Because evidently when you get to a certain height, a certain length of the original string, it ends up taking a lot more time with all the constant manipulation of the string. What can I do to make this faster? I didn't double back, right? I continually move forward. If the length of return string is greater than 0, should I try to move this into this? But then you have an else statement here, which is basically the same one as this. So maybe having the nested if statement, if else statement is messing me up. So let me try to omit that section by adding it in to this if statement. And that way I wouldn't need this else statement because it's the same thing as here. And let me put them back to the proper indentation. And let's run it again. Before it was 75 milliseconds for these 3 test cases. Let's see if there's any difference. It's even worse. I'm going to run it again. I'm going to submit it again, but it might just end up being worse holistically. 5.35 milliseconds. 5.35. And yes, it did end up worse. Okay, so that was a failure of us of a refactor so far. I still got 13 minutes. Okay, I can remove this. I really, evidently, I did refactor, but the refactor wasn't much of any difference. So it's the same big O rundown. The time is O of n representing the amount of characters in the original string. The space complexity is still O of 1. If the length of return string is greater than 0, maybe I should turn that back, seeing that it did better when it wasn't, when this if statement wasn't, didn't have, what do they call that? Didn't have 2 items to check, 2 conditionals. So as surprising as it was to me, I would have figured that that should have been the case. Nesting the if statements, I would have figured, and having an else statement that actually does the same thing as this one. But then again, if this runs, then you wouldn't have to worry about the else statement regardless. So, if S current index is equal I'm shooting in the dark, but part of me wants to change this to is not equal to the last item in return string and put the else statement, reverse the else statements. I know that that's not going to do any difference. Why would it? It's just changing the sequence of the if else. I'll be checking if they're not equal instead of checking if they're equal. But if that happens more times than not, that may save some time. I'm going to try it. I'm going to try it. All right, the last time was 107 milliseconds for these three test cases. It brought it back down to 79, but wouldn't that be about the same amount of time as the original one that didn't work through it, that didn't follow through with everything, that didn't work with it, exceeded the time limit with everything? So let's submit it again and see. I had 517, 560. Is a little bit better than the original one that actually worked, but still not good enough, evidently. I'm still at the bottom of the barrel. And the majority of people came up with a particular solution that was definitely much faster than mine. Less than 10 minutes left. Okay. I will have to go back and study string manipulation and see if maybe I could remove items based on the index. I'm just about sure that's not the case. And I wouldn't want to remove an item that came previously when I'm trying to look at where the current index is. But with less than 9 minutes left, I'm going to leave it here. Big old rundown, just to save myself the 2 points, is once again the same thing. O(n) time complexity, O(1) space complexity. And like I said, I'll leave it there, and I'll go back to the studies and see what I could have done better with the string manipulation. Thanks for building with me, y'all. I love y'all. I appreciate y'all. And thanks for sticking there throughout this. I thought this would have been a very easy, because it was an easy LeetCode challenge, but evidently some of them are tougher than others. Until next time, wishing you the best. You know, as I've been going back and forth and studying my old videos, I'm starting to wonder, maybe I should just go back to the drawing board and start studying my data structures and algorithms a little bit more before I bring this in front of you all. Now, this performance was a significant improvement to the majority of my others, but I don't know. I'm supposed to teach you all from my failures and my successes, but at the same time, maybe I should get a little bit better before I bring this to you all. Left with the 80, but then again, it was an easy question. This was my refactor after the pressure was off. As you can see, is still at the bottom of the spectrum, but is a significant improvement over the last refactor. As you can also see, I used a list, and at the end of that, I rejoined it to help increase the speed. I could do better though. If you appreciate what we're doing over here, don't forget to like, subscribe, comment, and share. All right, y'all. Till next time, you know how it goes. Keep building.